Hello students! So this little mini video for today's lesson is about factoring perfect square trinomials. So some of you may be wondering, okay, well, what is a perfect square trinomial? I'm glad you asked. Perfect square trinomial is a trinomial that is the result of squaring a binomial. And so as you're looking here, you see there that I've got a binomial. I've got a plus b, and it is being squared. And so remember that when you're squaring a binomial, you write it out twice, because again, squaring something or raising something to the second power means that it is multiplied by itself 2 times. So here we have a plus b times itself, so times a plus b. Over here to the right, we're kind of showing what that looks like using the box method. So if we do that and just kind of continue that, okay. A times a is a squared. A times b gives you ab. Again, a times b gives you ab. And b times b gives you b squared. Okay. So from there, if we write out those terms, we get a squared plus ab plus ab plus b squared. Alright, and so if you're looking at these two like terms right here in the middle, okay, the coefficient for this first one is 1, and the coefficient for that second one is also 1. I know this may look a little bit strange to you, having AB and AB. You've got those terms that have more than one variable in it, but again, the coefficient there is still 1. So since they do have the same variables with the same exponent, these two are considered like terms. So again, we can combine these two that say AB and AB. And again, when we put those two together, it's going to wind up being 2AB, because you're adding 1 plus 1, the coefficients. So again, that's going to look like a squared plus 2AB plus b squared. So when we square a binomial, the form that you're seeing here, this form is, oops, hold on, yeah, I just messed that all the way up. Y'all excuse me. That form is the form for a perfect square trinomial. So again, when you're looking at that form, and again, I'll show you different examples, but again, that is a perfect square trinomial form right there that we're looking at. Okay, again, this is the perfect square trinomial. I had left off the squared before, but we got it now. So okay, so you may be wondering, based on that, okay, so Mr. Starkey, how do I determine whether an expression is a perfect square trinomial? I know that you said here that the form for a perfect square trinomial is this form, a squared plus 2ab plus b squared, but I need to actually see, some perfect square trinomials to kind of help me, recognize what they actually look like, Mr. Starkey. So I'm going to show you exactly that. So let's say we were trying to determine whether or not an expression was a perfect square trinomial. So let's look at this expression right here. And we're asked here, is 6x plus 9 plus x squared a perfect square trinomial? So the first thing you want to do when you're trying to determine that is identify the leading coefficient and the constant term. This will probably be easier when the expression is written in standard form. Remember that we said the standard form for a polynomial is where it's written, where the exponents are ordered from highest to lowest. So first we're going to write this in standard form, and then we're going to identify the leading coefficient and constant term. So this is what the expression looks like in standard form. X squared plus 6x plus 9. Again, all of the exponents are written in order from highest to lowest. So in this form, if we look at that, the leading coefficient, and not just the leading coefficient, I meant the leading term. But the leading term here is x squared. So again, x squared is the leading term, and it's the leading term because that is the term that has the highest exponent. And the highest exponent here is 2. The constant term here is 9. Remember, constant means that it's a number written without a variable. So again, that is the constant term. Oopsie. So again, x squared is your leading term and 9 is your constant term. It's important to identify these two terms when you're doing this, because you're going to have to actually kind of use those when you're factoring the perfect square trinomial. Now we're not to the point yet where we're going to factor this, but once you've identified the leading term and the constant term, you need to make sure that both of those terms are perfect squares. They have to be perfect squares. So again, we see that those two terms are indeed perfect squares. They're perfect squares because they're written, or because they can be written in that form of something squared. Again, they're written in that form of something squared. X squared is the same as x squared. Of course, 9 is the same thing as 3 squared. And so, again, those two are perfect squares. The last thing that we want to make sure that we do is after we've actually written those two terms in the form of something squared and something squared, right? Then we want to make sure that that last term, that other term, the linear term, and if you got it in standard form, it's the term that's in the middle. You want to make sure that that term, that linear term, is equivalent to the form of 2ab, and again, that's the form of having it being the same as 2 times a times b. Okay. So let's say that we're going to do just a little bit of substituting here. Let's say that where we see the x squared here, let's say that is the same thing as a squared, right? Because again, we said that that's the form that it's in. And so if x squared is the same as a squared, that means that a must be x, right? Okay, so a is the same thing as x, because that's what's being squared there. All right, and then let's say that we've got 9 rewritten as b squared. So if 9 is equal to b squared, that means that the only thing that b can be, the only value for b that actually works, means that b has to be 3. All right, so if b is equal to 3, that means that 2ab, 2 times a times b, that means that must be equal to 2 times x times 3, right? If we substitute those values that we just put there, right? That a is x, So that's 2 times x, and b is 3. So times 3, right? Just plugging those values in for a and for b, right? So if that is the case, that means that again 2ab is actually equal to 6x. All right, and so in this little step of determining whether or not we've got a perfect square trinomial, again we're trying to make sure that middle term, and let me just scroll up real quick. The middle term that we had, or that linear term that we had, was 6x, right? You see it? Because again, we had already identified our leading term and our constant term. That linear term, or the other term, was 6x. So in this step, we were trying to make sure that term 6x was equivalent to the form of 2ab. All right, and we have shown just that, or we now see that it is equivalent to the form 2ab. So again, that is enough for us to say that this particular expression is a perfect square trinomial. So again, that original polynomial that that original trinomial that we had, 6x plus 9 plus x squared, it is a perfect square trinomial because it can be written in the form a squared plus 2ab plus b squared. So if we look at the formula for factoring a perfect square trinomial, it's exactly what we've just now talked about. So if you're sure and you've identified that you do have a perfect square trinomial, meaning that if you do have a trinomial that is written in the form a squared plus 2ab plus b squared, if that is the case and you know that that's what you have, then the factors, or at least the way that you'll write out the factors, is like this: as a binomial squared. Again, we know that technically you could write this as just one binomial times another binomial, but it's simpler to just write it as a binomial squared, where you don't have to write it as repeated multiplication. Okay, and so that will just be a plus b squared. Okay. I hope that this has helped with just explaining in part what a perfect square trinomial is, and explaining how it is that you can identify or determine whether or not you have a perfect square trinomial. And then again, folks, you can use this formula, which we'll do examples in the next video in part 2. But you can use this formula here for factoring a perfect square trinomial. And again, we'll show you a few examples in part 2 of this lesson, and that'll be a separate video. Stick around for part 2, guys.